Okay, we are going to solve some equations today though, okay? For the next 2 weeks, we are gonna focus on writing proofs. And writing proofs is something that will be a very integral part of this entire semester, okay? Proving that something is true. Okay, so we are going to start with something we know how to do, solve equations. Okay, so when we write a proof, we have to justify every step. Why did you do what you just did? So we need to talk about some properties. Okay, so if A equals B, then A plus C equals B plus C. Basically, if you add something to both sides, that's called the addition property of equality. Okay, so like if you're solving for X and you have to add 2 to both sides to get it by itself, that's the addition property. Okay, so what about our subtraction property?
A minus C
Equals B minus C.
So we have to get through those first. That means we can still.
We should do the big both thing tomorrow.
Mr. Barnett.
Wait, not tomorrow. We should do it on Monday.
Why not tomorrow? Tomorrow's Friday. Friday, Monday. They're in the 5 days.
Yeah. There's only one verse there.
Okay, multiplication property. Ben?
A equals B, then A times C equals B times C. Oh, and B, yeah.
The division property. If A equals B, then A divided by C equals B divided by C, as long as C does not equal 0. Well, we can't divide by 0.
Yeah, because then it's
Oh, I like that.
it's an answer that is outside of the realm of
Okay. All right, the distributive property. If I have something like this, what does this distributive property mean? Use your hand. What was that? Okay. Right? We go like this.
Now what you like?
You like,
Yep.
it would, yeah. That's what I was.
Mm-hmm. The distributive property. Yep.
Yeah, I remember it.
Remember, because the A goes to the
Okay. Now the substitution property. If A equals B, then A can be replaced by B in any expression or equation. The reflexive property. I want you to think about like a reflection, the reflexive property. What do you see in the mirror? And do you look exactly the same?
No, it's mirrored.
You ever just use another U trap inside of
We're gonna move past that. Okay. The symmetric property. If A equals B, then B equals A. Symmetric, we just flip it. Okay.
They asked me about.
Yeah, they asked me
They just really
Ooh.
They're like,
Yes.
I'm surprised.
I never got
because
that. Oh.
I got a pretty low
What
score
did
on
you
one of
get
them,
on?
but I got like a 71.
Nice.
I got like all
250 went down.
probability.
No, this
Like, we never learned that.
I got like 267.
Yeah,
Okay, we'll do a little mini lesson on it.
Like we skipped it like math 7, like
Right.
Yeah, they kept trying to get me to find circles, but I don't know how to find.
Yeah,
circles.
Okay, transitive property. Hey, guys, we don't have much time. Transitive property, if A equals B and B equals C, then A equals C. Okay. So now what we're going to do, we are going to work on 2 column proofs. Okay. The left side is going to be our statements. Essentially, they're going to be our steps. Okay. The right side is going to be our list of reasons, basically justifying each step. Anything in the reasons, we're going to be able to use properties, like we just wrote down how many properties. Okay. When we get into more like geometry stuff, we can use definitions, postulates, and theorems. Okay. Things we know to be true, we can use as reasons to justify each step. Okay. So what's going to happen? You are going to be given a problem and something to prove. So notice right here how it says given. That's what we are presented with. And then it says prove. Okay. So I will tell you right now, whatever your given information is, that is your first step and your first reason. Okay. Whatever it's asking you to prove, that is your last step. Okay. You always start with the given. Now, what's going to happen? We're going to practice this just using algebra. Okay. So we want to solve for X. We know that X is going to be 7. We have to prove that that's true. So if I want to solve this 4X minus 1 equals 27, what could we do to both sides? Not yet. We're right here.
Add 1 to 27.
Oh,
We need to add 1 to both sides. And if we add 1 to both sides, what do we call that?
addition property.
I'll say you can say addition property. And if you say ADD property, that'll also be fine. Okay, so from here to here, we added 1 to both sides. We used the addition property of equality. Okay, now from step 2 to step 3, what do we have to do to both sides to get X by itself? Okay, we have to divide specifically by 4, right? We would say divided by 4, divided by 4. Okay. All right. Turn the page. Division property. Mm-hmm. Okay, so you notice in number 2. Notice in number 2, our given information is this right here. So that's what we start with, and our reason is given. we want to end with whatever we're trying to prove. Okay, I'm gonna give you 30 seconds for you and either you and yourself or you and your elbow partner to fill out the reason for the second and third step.
Look at the bottom. Wait, yeah, I think you have to move it over to the other side, so.
Property, but yeah, same property. You guys wear white for home games? I thought it was a home game.
What is home game? What?
Oh, I don't want to go to Spain.
Okay, Brayden, what is the reason for step 1 to step 2? Okay, because we are subtracting 2 to both sides, right?
Yeah.
Okay, Alex, what is the reason for 2 to 3? Because we are multiplying both sides by -6. Okay, all right, let's look at proof number 3 right here. Okay. Here is our given information that we are going to start with. Our first reason is given, and we're trying to prove that x equals -2. All right, what's happening from step 1 to step 2? What are we doing, Clark? Yep. They distributed the -9 and multiplied it into the 2x minus 3. Okay. All right. Then, what do we do to both sides, Presley? We had to subtract 27, so they just subtract. Maybe I should spell correctly. It's overrated. Shh, don't tell her. And then to get -18x equals 36 to just x equals -2. Nora, what property are we using in that one? Yep. Okay, now that was nice. They did all the math for you. But that's not really what's gonna happen. Okay? You need to be able to complete both sides of the 2-column proof. So number 4 is more like what I'm expecting you to do. Okay? Here's the given information. Prove it to me. Now, sometimes you might have more spaces than you need, so don't panic about that, okay? So what do you think? Hold on, let me reply to this email. Okay, what do you want to do first? Just like that?
17 to the other side.
Okay, so this is where things get kind of complicated for me. It doesn't matter if we start with the x's or the constants, okay? As long as you're describing your work. So let's subtract 6x from both sides to where we have 7 equals 2x minus 17. And we subtracted from both sides, right? So we have the subtraction property of equality. Okay. All right, now what do you want to do? We're going to add 17. So if we add 17 to both sides, we would have 24 equals 2x. and that would be the addition property. Now, I am glad that Clark, you suggested this because this is gonna bring up something pretty important. Okay, to get X by itself, we would have to divide by 2, correct? So 12 equals X. This was the division property.
Doesn't matter which way X is, as long as the.
That is false. I want you to prove that X equals 12. We have proven that 12 equals X. Do we have a property that can take this and switch it to X equals 12? The symmetric property. Exactly what the flip. We flipped it. Okay, now, had we gathered the X's on the left side, we would not have had to worry about that. But since we gathered them on the right side, we did have to use the symmetric property to switch those places. Okay.
Why don't you take this before?
Okay, I'm gonna give you and your elbow partner a pink piece of paper. You need to fill in the statements and reasons. Now, normally this would be like a cut and paste. We don't have time for that. I want you to just like cross out what you're gonna use. Does that make sense? You organize how you want. I'll give you a couple minutes to do this and then we'll go over it.
We have to put this,
What?
the given one.
Well, yeah.
Okay, so statements would be.
Oh, isn't this the given? You do the, that?
Yeah.
There's like
Okay, what's the parentheses property? Yeah. So it would be 3x equals 2x plus 4, right?
Yeah. Yeah, to like give 1 to 1 side.
Yeah. Should we do minus
Wait,
2?
so-
Yeah, show it to be this. This one.
What if there's no axis?
Oh, you gotta
do two properties up for this to go down. But then we can yeah, but then we still have x minus 2 and that would not that if we can't put it down, but that would be that.
This one, this one, so this one, we need to leave that there. There you go.
So, yeah, you can still use 1 at a time and be okay, because if it subtracts to the other side, you just want it.
Yeah. Are we supposed to write it down?
Oh.
X minus 2.
Then you. Yeah, actually.
Yeah.
Yeah. Oh, goodness.
Addition.
It's like,
subtract 2x, so it's.
Oh, we already used our different properties. So how does this work?
X
X minus 2 equals 10.
What the heck?
We have to do something that makes this even more difficult. If you subtract this,
The flippity property.
that's subtracting. So we only have one, so that means no matter what, we're stuck here.
Okay, what the?
All right, let's go ahead and start going over these. I don't like this 30-minute class period thing. Okay, let's focus on proof number 1. So we have the given information. Okay, Harvey, what's our next step?
It's distributive.
Okay.
You times the 2 and you times the 2 and subtraction with x
Okay.
and 5. Then your next statement should be 3x minus 2 equals 2x plus 10.
Good. Okay, Sam, what do we do next?
You like.
Oh, to get x minus 2 equals 10.
Minus 2, just that.
Okay, and then to get x equals 12, we had to use the addition property, right? Okay, now, maybe you would have added 2 and then subtracted the 2x. It's okay when you're in control if those are in the different order, okay, it's fine. All right, it seemed like we were having a little bit more trouble over on this one. What are we gonna have to do first? The distributive property to get 7 equals negative 11 plus 3x plus 15, right? Okay, then what?
Substitution.
Is that like?
Why is the substitution right there? So, okay, so do you see how we have negative 11 plus 15? And so we would get 4 out of it. That's where we use the substitution property.
So it's not addition because you're not adding on both sides.
Correct. Okay, now if you told me combine like terms, I would accept that. Okay. Does that make sense? Okay, so then, oh, can we what? So then there's that one. So then we can get 3 equals 3x by using the subtraction property. We can get 1 equals x by using the division property. And then we need x equals 1, so there's where we do the flippity symmetric property. I think I have on the homework calendar student journal, but that's not actually what I want you to do. I want you to do pages 9 and 10 from your workbook. Okay? Yes, if you can keep it for reference or you can recycle it. I'll let that be up to you.